Hey guys, so welcome back. On the bench today we've got a Emerson radio. This is a model 641, I believe it's a 641B, and I think it's from about 1952. So I'm clipped onto there, and now I just cut this lead, so I'm going to go in there and just apply a touch to it. And let's hope we see something here. We're checking the primary. Primary is blown open. So there's your problem, lady. Yeah. So the audio output transformer is blown. Let me see what I can do about that. So what I'm going to do is tag this. I'm not even going to do the plug right now. I'm going to wait till I find the transformer, and then I'll go through and do a bit of a restoration on this. I think it's nice, but I don't know when I'm going to do that. It'll depend on when I find a transformer. So there's going to be a part 2. We don't know exactly when, but look for it. If it shows up, I hope you get a chance to see it. Thanks for sticking with me on this one. I think this has been kind of an interesting one, and thanks a lot. Talk to you later. Bye. Okay, so I hear you guys out there. What's the option? We just throw this in the trash can? Or do we see, well, if it's toast anyway, what do you say? Let's open this thing up. And we'll just see how it's constructed, if nothing else. So let me get started. I'm going to take this apart. I think what we have is, we're going to have elements of this that are shaped like an E and part are shaped like an I. It looks like to me the E is on this side and the I is on this side, because I think I can see a line going across here. So why don't we try it? What do we got to lose? Nothing. Let's go for it. Okay. I'm try to keep you guys in view here, but I gotta see what I'm doing too. Let's see. Okay, we're out of the shell. Alright, now let's see what we got. So this was the down part. And indeed, that's the E. As you can see the line across here for the I. So let's see if it'll separate. I think that's what I'm seeing. And I'm guessing it's the wax that's holding onto it here. You see the wax. It's kind of got those laminations held. I may want to heat this up a little bit just to make it a little less traumatic on the structure, trying to get it separated. There we go. Okay. There's our pieces. Okay. So here is what we got left. I don't know if it's going to be that easy to get out of here without heating it all up, so we'll just see what we get. I think heating it up is going to be the right thing to do. So let me get this warmed up just a little bit. See if that doesn't help it come out of the form a little bit easier. I don't want to risk, just tearing it up, just trying to get it out. I mean, I could just bang on it, but let me warm it up. It's warm. The metal on the inside will be the coolest part, right? It's definitely coming. And here she comes. All right. So here we go. Let the unwrapping begin. This is really the way to do it, isn't it? So here you can see the secondary and how they do that. That's kind of interesting. So they lay this heavy gauge wire through, then they wrap some strong tape around here. Then they wrap the wire around it and solder it, and then push that down, and then put tape around the outside. I wonder if there's any sign of the primary windings left here. They would be somewhere over here. Yeah, that's kind of the problems I had, is I kind of tore it up. I see one of the wires right here. You see that right there? There's one of them right on the edge of my finger right there. Good grief. Okay, I don't know if you can see it, but this little wire right here goes right into that gap right there. Yeah, right there. Good heavens, kids. It's right there. And it's right on the inside of everything. Well, it's the innermost winding. Unless it's near the very top, I don't think we're going to be able to do it. I mean, we're probably talking about several hundred feet of wire that is so small I can't hardly see it. Right? This isn't so bad. But this is just amazing. Okay. I may take one more desperate attempt to measure to see if there's any continuity left before I go any further, because any further than this, we're just destroying this coil. But it seems to be kind of at its end anyway. So let me see if I can get set up to try to measure any kind of resistance between that wire and that wire. I got to remove some enamel first. Yeah. So black is touching the copper wire, and the copper wire is touching the red. But black and red clippers are not touching each other. So I have good connection on both ends to the magnet wire, but I have no continuity in between. So there's definitely a break inside there. How deep in, I don't know. But the bad news is it's on the innermost core, which of course would make sense. And I don't know if I'm going to unwire this or not. We'll see. Okay, heck, let's go. Looks like the end of the wrapping might be around here somewhere. The nice thing about thumbnails is it won't go through the wire. At least not this big one. Bigger one. Okay, I'm gonna pause it and make some progress and come back later. So this is mainly involved using my thumbnail to scrape away at this stuff. Sometimes what happens is, it just kind of scrapes off like that. Sometimes you'll get a piece going and it'll tear, as you can see. So I worked my way down through this outer layer, and there's a strain relief layer that lays across this, that folds, is wrapped around the, so that these windings hold it in place. Once I got that up, now this one's ready to go. I can see that there's more than one wrap on here, I believe. You can see there's a wrap underneath here. Anyway, I can go ahead and start trying to unwrap this. So I think what I'm going to try to do is fashion some kind of take-up spool so that I can kind of wind it onto something else. I think I can find something for that. I thought it'd also be interesting to take a measurement of this wire and find out what its gauge is. So hang on a minute. Okay, fractions of an inch, sorry, decimals, 18.5 thousandths, or 18.5 mils. Okay, so let me look at a chart. Let's call it 25 gauge for fun. So we're at, which column is it? 32. So it's 32 1/3 ohms per 1,000 feet. Okay, let's see how much resistance we have here. Maybe we can make an estimate of the length that we have here. Let's see. Okay. We want to call that 0.9. We'll call it 0.9. Okay, so we said, let's say it's 0.9 ohms. And if we look back on our chart, we said if we assume it's 25 gauge, then that's 32.37. So 32.37 ohms per 1,000 feet. Okay, so we want to know how many feet there is. There are. Okay. Let's see if this works. So we want is feet. So what we'll say is that we have 0.9 ohms is for however many feet we have, is this ratio over here, 32.37 ohms per 1,000 feet. Right? So then we do a little bit of algebra and say, okay, then X equals 1,000 times 0.9. Okay, that's feet, that's ohms, divided by 32.37 ohms. Ohms will cancel, that leaves us feet. Dimensional analysis works. Dimensional analysis is your friend. All right, let's do it real quick here. If we can do it quick. Okay, 1,000. You can't see it. 1,000 times 0.9, of course, is 900. And divide that by 32.37. It's 27.8. 27.8 feet of wire. We say this coil, let's estimate what would be a diameter, just for fun. Let's say this is about 0.82 76. We just estimate. Let's see, if I said that's 0.8, It might be a little less than that. Let's say 0.75. All I'm doing here is just trying to guess kind of an average diameter. That might be a little small. Well, let's just say it's 0.75. Alright, so the number of wraps we're going to have times pi d is the circumference. The circumference is 27.8 feet, right? So we need to change that to times 12 to get inches per foot, because we're going to have this in inches. So just solve the algebra first. W, number of wraps, is going to be equal to 27.8 feet times 12 inches per foot divided by pi times the diameter, which she said is going to be 0.75 inches. All right. So let's see, does that work out? Yeah. Feet goes away, inches goes away, we're left with number of wraps. Okay, let's do that calculation. So that's 27.8 times 12 divided by pi, 3.14159, equals, divided by 0.75. I get 141 wraps. 141 turns. And what did we say the turns ratio was? 26? Call it 26. So that number times 26, 3,681 turns of that wire that's too small to see. Yeah, I'm probably not going to attempt that. I've got other things to do. Y'all check me out. Y'all check my mouth. Check my math. See, that doesn't make some sense. Okay, what do you say we give this a try? So I've got this mounted in a vise. I've got it on a shaft. It's held with a plastic bushing, kind of plastic piece here. There's a straw in there to give it some more or less lower friction for turning. I've got a washer that's spring-loaded up against this here to provide a little bit of drag, hopefully, so this just doesn't freewheel. Okay, and what I'm going to do is take this up on a spool. I only had about 2 feet of solder left on this spool you've been seeing me using, so I went ahead and took the solder off. I'm going to use this as a take-up spool. Now, you would be rightly saying, where's your counter, man? I'm not going to use a counter. Or another way to put it is, we're going to try to count it ourselves. And to prevent me from losing count, I'm going to video this and speed it up or whatever. I can count the turns in video later. But on the other hand, another way to look at this is that I'm not like loading this up with new wire. I'm going to take off the amount of wire that's here. I'm going to put that wire back on. I will have probably a difference in turns because I'm not going to be able to do as good as they did on a machine wind and with something that hadn't been bent on sharp corners like this has. But I'm going to give it a try, and we'll just see how it goes. All right. So I need to have a way to start to take this up and so forth. So I've got a way to do that. Let me, I'm going to have to be real careful, obviously, because you wouldn't want this to get out of hand. Come on. I need to get some scissors. Hang on. Okay, don't tell my wife I got into her scissors here. All right, so we're going to take some bits of this double stick. Okay. Just going to put that on here. Like that. Okay, I know that this wire is pretty fragile, so I need to be careful. Okay, so we got that peeled off here. Alright, so let me get it to my winding arbor. Okay, I'm going to use this to wind this with. Okay. Now, I'm going to have to be really careful with this and see if I can control the speed. I guess I want to go in this direction. So the question is, can I get the speed control where I want it? I'm just kidding. I got a better idea. I hope it's a better idea. Okay. No jokes now. This should work, right? Okay, so we want this to go in this direction, right? So I'll be winding it. Tip you up a little bit so you can see, maybe. Okay. So I'll be trying to wind it right here. Going that way. Okay, so now the question is how do I know how much I've turned it? I'm going to use a little bit of fingernail polish. Don't tell my wife I stole her fingernail polish. Actually, truth is I use this on some of the restorations I do to replace missing writing on things. I'll put a picture of a restoration I did several years ago of a turntable on a Magnavox. Okay, I can see where the other black wire comes out, but also I've got a white marker there. Maybe we can see it. I don't know. If we can't, we won't be able to, but we'll just do the best we can. Okay, we ready to give it a try? I am. Let's give it a try. Okay, so I'm going to stick this through that hole, like that. A little further. Bring it out like that. Are we ready? One. I've already lost count. We'll keep track of it in audio. in video. Y'all keeping count for me? I have already lost count by a long shot, but we'll see. I think that the tolerance on these is like plus or minus 25%. So we'll see. I'll tell you though, if that little wire has got this kind of tape on it, it'll probably break all the time. That's kind of why you don't want to go too fast, because it's got this strain relief configurations of the tape in here. There you go. 147 rounds, I counted it. Just kidding. Okay, so there is our secondary wound up. Okay, now we're down to the nitty gritty here. Probably wondering, hey Fix, what's your big plan now? You can't even see that wire. That's true, I really cannot. But I've got a plan. I don't know. We'll see. I'm going to have to work my way through this layer of wax and get to where I get to that primary down at the bottom. So let me work my way through this and I'll bring you back. It's like there's a clear type of tape around it. I hope it's not like dipped in varnish or something. It's got this white band across here. Makes me wonder if maybe they make these things to this stage, tape it off, and then they put them into inventory, and then they wrap the secondary on there depending on what winding ratio they want. That might be an interesting way for them to manufacture these things. Don't know. Got to keep digging. Okay, I don't know if you guys can see this or not. I'm going to do my best to show you. I cannot tell if you can see that or not. Can't tell if the focus is cooperating or not. Let's see. I don't know if I can do any better than this. So here is the end that I was using for testing. If you can see that there. There's an end right there. Can you see it there? That's the end I was using for testing. So we've reached the end, and for those of you who always wondered, it is wound in the same direction as the secondary. Does it matter? I don't know, but in case you ever wondered, that's the answer. It's wound in the same direction. Okay, so now what I've got to do is rig up a take-up for this. Okay, so I've got a different way I'm going to wind this. I have no really hope of being able to count this, the number of turns. I just don't have a winder. If I want to rewind this, maybe I'll get one day, but I've been trying to just get by with what I got, right? So I've got a way to take this up. Now, you may be wondering, so what are you going to do? My intention is to start to unwind this until I find the break. Hopefully the break will come apart, and hopefully that's the only one. So when I find a break, I'll test it to see if then I have some kind of continuity to the rest of the bottom of the coil, if I can find it. And then try to repair that, and then wind back how much I took off, and then put the secondary on. So that's what we're going to try. I'm going to rig up what I'm going to try to do for the spooling this off, and I'll bring you back when I got that set up. Okay, so what I've got concocted here, almost embarrassed to tell you. So here is where it's letting the spool come off. The wire is right here in my hands. I don't know if you can see it. And it comes down to a friction reel. I bought this from my dad like 40 years ago and never got used. I've got it in, and I've looped it around the post, and as I take this up, this is coming off and then winding up in the same lay that it had before, so I'm not working it back and forth. This is too tight of a friction grab on it, so I'm going to have to release it. But it seems to be working. So there's no hope to count this, so that's a futile thing to worry about, really. So we're just going to go. And by the way, it goes underneath a level wind bail that's going to go back and forth, so that's kind of cool, right? All right, let's just see where we can find the break. Hope it's not too far in. I was hoping it'd be right up here near the top. Not going to be. Okay, we'll just see how far we got to go. Yeah, I'd like to lay another layer of tape down midway through. Man, I was really hoping we were going to get to the brake well up by the top, not this far down. That's a lot of wire to try to put back on level. I'm afraid this is the easy part. It's like every time it makes a wrap, there's wraps of paper that go around it. So the bad news is I'm still going. A minute ago I thought I'd reached the very bottom. I didn't, but I'm not far off. Guys, I'm afraid the brake on this is going to be right in the base of the core, and this entire thing is going to have to be rewound. I don't think I can do it. I've lost track of how many layers there are. See, I just finished another layer. I'm just going back the other way. And you see this tape in between each layer. I've been doing this for a long time. I've pulled a ton of wire off this thing, and I haven't found the brake yet. I'm assuming it'll be parted and it'll be obvious. Well, you know, to have the brake up near the top was kind of counting on luck, right? Sometimes it's not all good luck. So I'm going to keep going, even though I don't think I'm going to be able to rewrap this much of this fine grade wire without a winder. And even then, just getting the level wind part is going to be difficult. I'm going to keep going and we'll see what we find. At least that way we'll do a post-mortem. I mean, look how many wraps that is. We're just going to town on this thing. Kind of paper tape that's got acid in it. You see the paper's turned brown. Just like the paper I guess they used in capacitors. There's plenty of layers below this. We're still going. Okay, so I've gone all the way through to the, I believe, the last layer, and I finally had a wire break when I was pulling it off of here. So what I've done is I've verified that I am on the end of that wire here, okay, and I'm trying to see, okay, is the break between here and here. So up here I pulled the wire out that goes to the terminal, and I'm getting still no continuity. You can see that. Can't see if you can see that, but anyway, but I do know that I have connection here. So looks like the brake is on the last wrap of the primary. Isn't that the way it is? Okay, let me see if we can find it. So what I'm going to need to do is tie off the brake here with the other end of the brake. I'll solder them together later if I go that far. So I'm just going to basically J-hook them together, but not solder them. I should be able to find this later. Okay, let's find this brake, huh? On what looks like the last wrap. I've been out here for hours doing this. Would I recommend doing this again? Well, if you get lucky, and the brake's near the top, then yeah. But sometimes luck doesn't go your way. And this is just such a case. Yeah, this is definitely the last wrap. I'm glad you're along with me on this. Okay, where is it? Where is it? There it is. Okay. I know you can't see it. There's the brake. And it's on the last, it's like almost to the end of the last wrap. Can you see that? I'll bring you so you can see. Okay, going all Shingo on this here handheld. Can you see it? So the wrap typically comes to about here and wraps back and forth. So we just had it break. It's in this area here somewhere. I have to dig around to find it. But it's on this last wrap somewhere. When I find that, I'll dig it out and we'll see if we get continuity to the other bitter end, and then we'll know we found it. Is there any hope to rewind all of this? Okay, I think I found it. I may take this under the magnifying glass to show you guys what I'm seeing. Yeah, I'm going to go to the magnifier. Okay, we'll see how this goes. So I have you under the microscope, and if we come here, you can see a broken lead right here, right there. Okay, now if we go to the other side, follow that break. Here's what we see. So I can get you in focus. We've got a couple of broken wires here, two in fact. If they lay down right at that corner. So I suspect it might have gotten bent a little harshly there, maybe. Caused a little bit of local higher resistance, maybe. But maybe that's why it broke on the lowermost level. So you can focus in on that a little bit better. Doing the best I can here. Yeah. So anyway, maybe my imagination, but it looks like to me that this one that's closest to the coil has a little bit of a burned look to it. The other one's got a bunch of wax shoved onto the end. I can't get it off. But this one looks like it was burned. It may have burned them both through. I don't know. So I'm going to try to take this outermost one away. If I can. All I can say is this is not as easy as it looks. All right, so I'm going to pull off that last one. So here's the coil form coming into view, and then this is the other end. I've pulled that quite a bit. Anyway, so what I'm going to do is go clean this other end up, make sure I've got continuity, and then we'll figure out what we're going to do next. But see, there it is, right? Get away from this. Where is it? There. Okay, we're back down in the shop. It's a pleasant 92 in the shop. We had a little bit of cloud cover. It got down to 94. We're all just excited. Okay, so what we have here is, here's the coil that we were looking at under a microscope. And this is the part that broke off. I'm going to put it down against a white paper. It looks like you can see it better that way. So it broke at the end of this piece here. Then this piece was still attached and went around. And then this other end is where it broke off of the spool where I was spooling it up. So as you can see, that might have been where the initial break was, I don't know, but then it broke again here. So there's like a piece that was still there, and on one end you saw this end and this end of it still there where it went around another time. So anyway, this is a part that's gone now. I had 2 breaks is what I'm trying to say, and then the one I made happened, which is further down. Okay, and now this is the piece that was broken inside the coil, and if you can see it, there's another piece right here. And that is the exit piece that I've been doing testing against back when I could get, this is the part that comes out to the primary winding, comes out to the audio tube or the B+. Okay, so let me scrape the insulation off of this and see if we've gotten ourselves any more breaks in what's little left of this coil. All right, now let's see. Well, what do you know? Well, what do you know? We finally got to the point where there are no more breaks in the coil. I was hoping that's about as many windings as we would have had to take off the top to find the break. Instead, that's all that's left of the entire 3,000 some odd winds on this. So I don't have a whole lot of hope of winding this back up, but at least there's a post-mortem. There was a break inside, it looked like it was broken and burned through 2 wires, and then that's all that was left, and it was the very bottom of the coil. So who wants to give this a try? I made some measurements and found out that that is 3/8 of an inch. Basically, you could set a socket of a 3/8, like a 3/8 socket set. You can stick the 3/8 part into there, the square it fits. So I went to Tractor Supply today. It's where I got the thermometer. Carriage bolt. This particular carriage bolt has 3/8. I think this is a 7/16. I could be wrong, but anyway. Look at that. So that fits that coil form. Doesn't go all the way, but it doesn't need to. It just kind of holds it in place. Okay, I'm going to go burn some threads off of this. Back in a minute. Okay, I don't have a lathe. So I just took this to my bench grinder and ground off the thread that's on here, and I'll show you why in a minute. So this can fit under there. Yep. Okay, I'm going to try something here. What are these parts I bought? Got a rubber washer. Okay. I had to chase this with a die to make sure it would go on. I had to clean it up a little bit because it had messed up the thread crest a few places. don't have to squeeze it tight, right? But now I might put another nut on there and jam that nut so that I'm not having to squeeze this to hold it on there, but it'll provide just a little bit of a squeeze. I'll have to dig up another nut for that. Let's see. But now what I can do, back you up. I took this guy right here, and I found I couldn't hold on to it anywhere until I realized it was a screw hole right here. It must have been maybe for putting a handle on here. It's been long gone. I've had this for 35 years or so. So I put this in and snug that on, lock that on, and that's got a hold of that pretty well. So I can hold that with this, and that allowed me to operate this handle. So now I had to take these threads down so that it would fit inside this chuck. And it does. I mean, none of this has to be tight, right? Like I say, I think I'm going to put another nut here and lock these two nuts together. But then, can I do this? I mean, I know about the winder they sell online that has a counter, which I may get one day, but I don't need a counter. I'm just going to put the same amount of wire back on. So I'm just going to assume that it's going to be within the tolerance. And if it's not, we'll measure it. So I'm going to give this a try. I mean, why not, right? Okay, I found another nut. Now, you may not have noticed it, but on the coil, there was a margin between where the winding goes and the actual end of the form. There was a gap there. That was about the width of this piece of cardboard. So I'm going to put that back in there, and what I did is I just cut some random pieces of cardboard and stuck it in there. I think it's okay. And they're about the right width of that little place right there. And then what I'm going to do is try to get these to be relatively straight. Now the part of the core that goes to the terminals, I pulled it out a little bit further, and I'm just going to pull it around the side here. I'm going to tape that down for now. It's going like this. The part that's going to be going out to the terminals is out towards the nut. Let's see if this will... It's back onto the carriage bolt. Those on, these on. Get this snug down, and then I'll see if I can straighten out the cardboard some. I don't know how well these little form pieces of cardboard will work. Pretty flaky looking, I know. Alright, so then that'll go into here. And then there we go. Okay guys, wish me luck. Okay, so last night I attached the lead that's on here to the take-up that I did on the bait casting reel, and secured it down with a little bit of tape. Also the lead that goes to the B plus, or the output tube. I'm trying to find it. Hope it's still here. There it is. Barely see it there, looping over. I've got it taped down here. This is just masking tape. So I soldered this, and I tested continuity from this point through to a point over here. I scraped a little bit off over here, well past this, and verified I do have continuity between here and here. Now, you would think, well, why didn't you test against the end in here? I did leave the other end out, but during all that winding I lost track of it, and it got wound up inside here somewhere, so I don't know where it is. So as I was looking for it, I was looking in here and I found at least one other break on this line that was taken up. Now how it didn't break when I was doing it, I don't know, or how it broke later, I don't know. Or maybe that's the end poking through, I don't know. But I'm just not sure. So anyway, we're going to go give this a try. It's only 86 degrees outside in the shade, so I'm going to go out and try to get this done before it gets any hotter. So we'll just see how it goes. Nothing to lose, right? Okay, I've got the reel set to where it'll pay out. I'm not going through the level wind, just coming off the top. This is the solder joint that I did, and we're just going to see what we can do here. Long way. Alright, we'll see how it goes. Wish me luck. Kind of going slow at first to kind of get the hang of it, but I don't want to take all day either. Gosh, this is kind of making me dizzy. First break. Okay, I'm going to have to get the soldering station out here to help me out. So I'll go get that, and we'll see how we do. Okay, I got the first break repaired. Let's see if we got any continuity. We do. We have continuity, miraculously. Okay. That was 25 minutes work. Let's keep going. Okay, let's keep going. The reason this isn't perfectly wound is because I've got a wobbly bolt, right? Otherwise, I've got machine precision fingers. You know, this wire that's, I don't know, 70 years old, I've tried not to bend it back and forth, you know, to fatigue it, but I don't have a lot of confidence. I'm not going to have a whole lot of breaks in here. We'll just have to see how it goes. So still moving right along. The problems that I've had so far is every once in a while a bit of the wire will get hung up on the edge of this raggedy cardboard I have on here, and it'll form a loop up here. So I have to back up and get that all unwound. One of them, it just had a little bit of a loop. I just laid it down, put tape over it. That's not going to make any difference. But the other thing I've done is, you may have seen it before, is I'm laying these in here. I noticed that when I took the foil form apart, that they would have things like strain reliefs. What they would do is lay a piece of tape down, have many wraps over it, and then lay this over again and wrap it again. What that did is it kind of held the edge in on the side of the coil on the form. So I've done that a couple of times, and I've used that also as a way to try to hold down the troublesome areas of this cardboard that are in the way. Cardboard's a real pain in the neck, but hopefully it'll turn out okay. Would I do it again? I don't know. I'll reserve judgment until I'm done. But it's nice to also have the tape because I can kind of see how I'm doing. Because otherwise it's just a mass of wire. I can't see how it looks. But doing it this way, I can kind of see how the coverage is going and how my not so level wind as level winding. So anyway, we're making progress. I can see the bottom of the fishing reel here, so we're getting a little closer. It's time to find another break, I guess, but I'm trying to think positive. So how long have I been doing this? About an hour. That one break I had took me quite a bit of time. I forget now what I said, 15, 20 minutes, I don't know, to fix it, because I had to get all my gear set up out here. Took a while to get my soldering station out from behind my workbench. I was trying to find my travel iron, and I may have left it at a friend's house, so I just pulled this one out. Okay, we just had another break. Right there. Okay. But look how close we're getting. I don't know if you can see that, but we're getting close to the end, so I'm actually fairly satisfied if that's all the breaks I've had. So let me get this fixed, and I'll bring you back when I'm done. We're almost there. Okay, I think I've got the second brake fixed. Let's double check it. There we go. 225 ohms. And there's the repair. Okay. We're almost done. Let's see how many more breaks we got before we get to the end. Hopefully not too many. And I may start to fold those other tapes over before long. Yeah, I think I will. I think it's time. Okay, so this one. Now the sticky is facing up. So we'll rely on the windings to hold it down. Nice to see this live, to see what it's really like to try to do this. Okay. I'll go to this one. Hope that makes sense to you what I'm doing with this tape. Like I said, this is something about the construction of these things I noticed when I took it apart. Can you believe it? We have reached the end. So I guess I imagine those are the brakes. It must have maybe been the bitter end sticking out. We have reached the end. Do we have continuity? Well, let's see. Here's the end. Okay. You watching? Let's see if we manage to do it without leaving a gap somewhere. Okay, let's make sure I have a good place here. Don't panic. Nobody panic. Come on. Okay. Woohoo! We rewound that primary. 231.5 ohms. Well, what do you know? What do you know about that? All right. Let me tape this thing up and get it secured. That's great news. What a success. I figure that was worth it. Hey Fix, what do you charge to doing these coils for me? I don't know. F-150? Seems fair. Okay, so we got that all wrapped up. And we'll do another check here. There we go. Resistance through the primary. It's good. So as I take the E-form and I look at this and say, am I going to have any room left for the secondary? Very little. It's going to be awfully tight. And it's just the inefficiencies of not using a machine wound and leveling. So I'm just going to do my best to pack it on there. We'll see what I can get. All right, we're going to begin. Let's see how we do. I'm going to do this last, the secondary here by hand. It's only 30 feet or so. I'm just trying to make it as efficient as I can get it. But I'm going to move you aside because I need to be where you are so I can see what I'm doing. Okay, almost done here with the secondary. Just about to come off the spool they used to take it off on. I've got it kind of stuck through one of the toggles for locking down the swivel on the vise, just to give it a place to rotate upon. These other bits of tape here are just there to, as I said before, is to kind of hold the edges in. Now, is this going to fit inside the E-form? I don't know. Okay, I'm at the end. Maybe if I hammer it, right? Don't laugh, maybe I will. If it won't fit otherwise, why not? Okay. Okay, so one foul up we've got is for somehow or another I managed to get the primary winding to come out the same size as this. When I started the secondary, I somehow got out of sync. So I'm going to try to move the primary windings over to the other side. You weren't expecting perfection, were you? As I said before, is it pretty? No. Does it need to be pretty? No. Does it work? We don't know. If it does, then I've done my job. Okay. So what I need to do is get these two primary windings. I want them to be 180 out from this winding. Okay, I went back and put some of this high temperature tape on here. Now what I want to do is get these primary leads to be 180 degrees away from the secondary leads. So I'm just going to bring them up. Okay, so I need them to come out about where I'm showing them. Okay. Okay, so what I've done now is I took the original leads that went to the primary, stripped the ends off of it, taped them down individually, and the little wires that go to them are right next to them. So now that I get those secured, I can put another reinforcing wrap around all of that, and then get into soldering them. Then I'll bend that end down over that piece of tape and then wrap that, and that should be solid. Or at least as solid as it was when it was made, which held up pretty good for 70 years. Okay, I got the connections soldered. I'm about to fold the joints down. Sorry for the creaking here. But yeah, we got 235 ohms through this thing. That's on the primary. So lay that down and then I can tape around it. It'll get more tape on it, but I want to make sure I can get this into the coil form before I build up too many layers. Okay, we're still good. I'm just as surprised as you are. Okay, so we got the secondary soldered on. I thought about doing this trick again, but I don't have enough room in there really. I'm going to have a hard enough time getting the coil form on, so the core. So we'll see how we get. Okay, we're at the moment of truth here. Let me check the continuity again. Secondary. There we go. Come on, quit messing around. There's that 0.9 or so we were using before. And then we'll get onto the primary again. Wow. Okay, so now the trick is can we get the coil form into it? We'll see. Nothing like, we just might have to resort to a big hammer, right? Well, I'm surprised actually we got this far. And if I'm not able to get any further than this, it was still a good experience. So we'll see how we do. So it was 82 when I came out here. It's 98 now. I'm going to pack this up and go inside and try to see if I can get the core in inside where it's a few degrees cooler. Okay, back inside where it's 6 degrees cooler. It's only 93 where I'm sitting. Okay, I've broke loose the jam nuts, and I'll get this off our little arbor here, and then I'll go get the E-plates, which I think I left outside, and we will see. I think it's going to be way too big. Before long, I'm going to be beating on this with a hammer, right? Yeah, it looks like it could have been wound a little tighter in there, doesn't it? Well, that's the secondary. Oh well. Oops, just peeled a piece of it off. All right, let me go get the core and we'll see if it'll possibly slide in there. Okay, here's the elements of the core. I think we're going to be way out of luck, but this was an interesting experiment. Let's see. So this is going to be in here like this. So I want the winding, I want the wires to come out here. I'm holding my breath. How should I just fold this over? Like that? So this piece is trying to get away. It's close. It is close. I don't want to push on the core, I mean the form core in the middle, because I'm afraid it'll either crush or scoot through the inside of the winding. I'm going to take some time with this, and let me get you out of the way so I can see what I'm doing, okay? We'll see what we get when I get back. So at Hobby Lobby they had 3/8 inch square stock that I got because I thought maybe I would be using it for the unwinding operation. What I found when I was trying to push the E-core in is that it was trying to collapse that square inner tube. So what I did was I put this wooden tube in first all the way in, and then what I did is I pushed the E-form up against the wood, and now I'm sliding it up off the wood onto the core. You guys can see that. I'm trying to get to where you guys can see it without much of a shadow. For everything I'm trying to do, that just makes things a little more fun. Okay, how about this? Oh well. I don't know what to think. Did we pull it off? What do I do with these loose wires here? Maybe I'll just put some tape across here. I may just go ahead and do a wax dip as well. I mean, does anybody know that somebody did this at home 70 years later? Well, let's finish the assembly. Like that, right? And then we fold those lugs down. Now, I'll tell you what I'm going to do. Before I go any further, I'm going to think about So when am I going to test this? I guess I need to secure this. Let me get this secured. I'll bring you back. Now, I don't have a megger. I used to have one years ago at work that I could use, but I don't have one now. But I saw the way this is built. I don't think I'm going to need to worry about a megger check. All right, let's check these things one more time, and then I guess we'll do the tests on this. Okay. Emerson seems to be watching intently. This one's over here says, "Sure, use me as a prop." All right. Secondary. Secondary. Continuity. All right. Primary. All these green alligator leaves are going to go right in the trash. Okay. Primary. There we go. Okay, got the microphone turned around correctly. Okay, so we've done the primary and secondary checks. We have continuity through the coil. I guess the rest of it is up to physics. So how do we test this? I guess we could repeat the Uncle Doug test to see if we're getting anywhere near the same turns ratio as what we thought. I don't know how close to hope it is, but maybe what we could do is back into the load resistance that the output tube is looking for and see if this coil will work, if you see what I'm saying. It doesn't have to match that per se, it just needs to work for that application. So let's see, if we're going to rig up the Uncle Doug test, what we need to do is get another meter in here. Let me get that all set up. Okay, we're ready to run the turns ratio test as outlined by Uncle Doug. Okay, so this meter is measuring the output voltage in DC, and I'm going to raise the input voltage until this reads 1 volt. Then this will read in volts the turns ratio. I've got this set at volts AC, and I'm connected to the primary. And I'm bringing in the AC from the variac here into the primary. Okay, let's get this thing going. Alright, variac coming up. We want 1 volt out on the meter on the right. I think earlier on that other little coil we had, was it 27.5? These are like plus or minus 25%. Okay, we're at 25 to 1. We're at 25 to 1 on the turns ratio. Okay, let's see how this thing works. Kind of like I did when I fixed the output transformer from the Grinnell. I hooked it up to a audio signal generator, and I'm just going straight to the speaker right back here. And that way we don't have to worry about how the radio is performing. We're just going to be looking strictly at the performance of this and see how it works. So let's see how we do. I think we got a success. Well, what can you say? I'd rather be lucky than good. So I guess you can fix this with some pretty, crummy tools and a whole lot of time and patience, but just give it a try. You never know what you're going to get, and it looks like it works. We'll have to see how the whole thing works together someday if I ever get around to working on this guy, but there you go, guys. I mean, it seems to be good. Well, guys, so I must say I did not have this kind of high of expectation. Mainly what we wanted to do was kind of see, is the break near the surface, because it's something that we could fix easily. The answer was no. We had to strip this thing all the way down to the bottom to find where the fault was. At that point, it was kind of like, to me, it was kind of like, this is not really going to work. But, we tried to put this thing back together again, with some improper tools, let's say. But if I had a coil winder with a counter and all that, I'm not sure I would have got a better result. I just wound this as kind of my first attempt at doing something at this scale. I'm sure I did some things wrong with the way the construction is done, but I certainly didn't expect to be able to get this thing back to working. So there it is, plugged in. Here's the other one, not in, and we're getting performance out of this thing. I've checked the voltages on the output tube. And, I've got 100 volts at the plate. I've got 85 at the screen grid. It's got 0 at the control grid. The cathode's around 5 volts. So the voltages there all look good. Sometimes I think I can detect some distortion. I'm not going to be very critical on this. I'm not going to worry about it. I'm just amazed that we were able to get this apart, find where the fault was, do the best we could, get it back to where it is, and the thing's playing, so whatever. I think that as far as what to do next with the radio, I may use this, get the rest of the radio working and performing like it ought to, and then we'll see. Like I say, I'm sure there's something fundamentally wrong I've done here, but heck, it's fundamentally working, so there you go. Anyway, so there you go, guys. Thanks for watching. Appreciate it. Take care, guys. Bye.